When it comes to databases, being able to query structured data is what makes it a database in the first place, as opposed to another product like Firebase Cloud Storage. But how do you query data? I'm glad you asked. Let's talk about queries on Firestore Enterprise Edition. Enterprise Edition? What's Enterprise Edition? Firestore is offered in two separate editions, Standard and Enterprise. While we've covered queries on Standard Edition in the past, Enterprise Edition adds new querying capabilities that enable better performance and more flexible app architecture. In this series, we'll talk about those expanded queries, what they can and can't do, how to use them, and how they work so that you can have an intuitive understanding of Enterprise Edition before you go use it. First, let's talk about how Firestore stores and organizes data. The data model for Enterprise Edition is entirely unchanged from Standard Edition, so if you're a veteran Firestore user, you can skip this section and jump ahead to learning about indexes. If not, stick around. Firestore is a document database, so instead of the classic rows and tables of a relational database, Firestore stores data in JSON-compatible documents, containing named fields mapped to objects. Documents are contained in collections, which are, as their name implies, collections of documents. Collections can be nested under documents. Firestore queries also don't fetch subcollections when fetching a document, which is a good thing, since collections can contain an unlimited number of documents. If you query a collection without explicitly specifying an order, the return document order is not guaranteed. More on that later. Collections can also be heterogeneous, so not every document in the collection needs to have identical fields. Now that we have the basics down, let's move on to the fun part. How do you actually read data, and how do you make it fast? Reading data is accomplished through querying. At its most basic, querying is just describing what data you want to receive from the database, which the database then fetches for you. But how does the fetching actually get done? Does the database just look through every document in a giant for loop? That's where indexes come in. Indexes are just accessory structures that store document data in a way that makes it easy to find relevant documents for a given query. In both Standard and Enterprise editions, Firestore makes extensive use of ordered single field indexes, which are indexes that store a single field of a particular document by order. That's why we call them ordered single field indexes. Additionally, Firestore also allows you to create indexes that combine more than one field's data into a single ordered index. This can be useful for things like filtering documents in a collection based on matching values across more than one field. For example, give me all recipes sorted by rating and then by name. And Firestore provides collection group indexes, which are indexes that combine multiple collections that are similarly named into a single queryable structure called a collection group. They do this by collection group name, so be mindful of what you name your subcollections. So that's a Firestore index in a nutshell, an ordered list of field data mapped to document IDs. Though both Standard and Enterprise editions use the same index types, Enterprise Edition is capable of scanning all the documents in a collection to execute queries, which is called a collection scan. Firestore can also combine scanning indexes with document lookups on the same collection. As you can imagine, this has implications for performance, which we'll talk about in a future video. The key difference between Standard Edition and Enterprise Edition is that while Standard Edition automatically creates indexes for every document field, it only supports queries which can run using the existing indexes. Enterprise Edition does not create any indexes by default, but also does not require using an index for every query. This gives you the flexibility to both run any type of query and also manage the storage, write, and read performance of your database more granularly. In Enterprise Edition, you'll generally save on storage costs for all the fields you don't end up indexing. And since Firestore won't have to keep all those single field indexes up to date, your write latency and write performance scaling will massively improve for documents with many fields. But it also requires you think about queries a little differently. Let's recap Firestore queries as we know them in the Standard Edition, what we call core operations, and then we'll get to the Enterprise Edition. Before we can get into the details, I'm going to go over some terminology. Core operations are our umbrella term for every kind of read or write operation available in Firestore Standard Edition. Since we're talking about reads, in practice that means every query that can be written using the query API in our SDKs, the query method. They're also available on Firestore's Enterprise Edition, though the Enterprise Edition may employ some different query resolution strategies. More on that later. I'll be using core operations and later on pipeline operations to refer to just reads, even though they both also include writes, since this video series is focused on querying. Core operation queries are queries that can be run on an indexed collection, meaning if you create an index, your query will always be fast. Queries run against a standard edition database are always run using an index, and on Enterprise Edition, they'll run on an index if available, otherwise they'll fall back to a collection scan. We'll get to pipeline operations in a later video. On Standard Edition, Firestore generally uses the same strategy with a few variations. First, it identifies an index to support the query, given the query's collection and any sorts or filters. Then it traverses the index until it finds the first entry from which it can begin scanning. The ordering in the index is what keeps this step fast. Finally, it scans through index entries to find the documents it needs to return. How it scans can vary depending on the query's needs, but it always scans all of the documents that need to be returned by the query. This is the reason why the query performance scales with the size of the returned document set and not the size of the collection. This means that in order to run any query on Standard Edition, the results for that query must be bound within some well-defined upper and lower limit in the index used to support that query. So for some queries like a simple ordered fetch, Firestore can simply scan all of the index entries in order, while for more complex queries like multiple orderings with limits, Firestore can determine the upper and lower bound within the index, and then scan within that range and skip documents that don't match the query. And some of you may be thinking, wait, what about count, sum, and average aggregations? These simple aggregations are calculated by iterating through the index rather than reading documents, since those indexes contain all of the information needed to calculate sum, average, and count. Counting the number of documents in a collection is a special case because you technically don't need any index data at all. You just need the size of the index to be the same as the size of the collection. Although having an index sounds like a pretty heavy constraint, core operations queries are still powerful, allowing you to run any sort or filter on one field, any number of equality filters on multiple fields, or with the help of composite indexes, range filters on multiple fields. Remember, the order of returned documents is dependent on their ordering within the index, which is why when you create multiple field indexes, Firestore will ask you whether you want your entries in ascending or descending order. There are some cases where the inflexibility of core operations will limit you from implementing certain features though. Let's say you're building a social media website where people can like posts, and you have a collection of posts that looks like this. If you want to view all user IDs sorted by the average score of all of their posts, there's no way to do that in Standard Edition because the index can't store this particular ordering. And since there can be many posts that update frequently, storing an average score field on the user isn't appealing either. And I know some of you are familiar with Standard Edition's index requirement limitations because you post about it in YouTube comments, sometimes under videos that aren't even related to Firestore. I have good news for you. In the next video, we'll dive into extended query capabilities on Firestore Enterprise Edition and what this means for your applications. See you next time.